introduction part is understood, right? If so, then we'll start our exercise. 5.1 exercise. So here there are around 34 questions in this exercise, and all are very easy. Prove that the function f of x equals to 5x minus 3 is continuous at x equals to 0, at x equals to minus 3, and at x equals to 5. At all these 3 points, you have to prove whether they are continuous or not. It's very simple. If I take limit, I'll solve one question so that we can try all others. Yeah. At what point they said, for the example, I want to find limit x tends to 0. Not this one. Limit x tends to 0. If I put, what is the function is given? 5x minus 3. So whether it is left limit or right limit, it is going to be same. So if I substitute here, I'll get 5 of 0 minus 3, which equals to 0 minus 3, which is equals to minus 3. So left limit or right limit is going to be minus 3 only. Then if I find f of 0, f of 0 also will give me 5 times of 0 minus 3, which is also equals to minus 3 only. So left limit, right limit is giving you minus 3. Functional value is also minus 3. Hence the function is continuous. Or maybe you can say every algebraic function is continuous. 5x minus 3 is a algebraic expression. So hence it is a continuous. Similarly, you have to check for minus 3. You have to check for 5. Just substitute. If I go for 5, it will come 25 minus 3 is 22. So function value will be 22. Even limit value also will give you 22. Hence it is continuous. You can use any method. You can use this limit method like we did here. Or maybe use that formula. Every algebraic function is a continuous. And 5x minus 3 is the algebraic equation. So hence it is a continuous function. So both the ways we can write. So these are 1 mark questions basically. Now similarly, second question also examining the continuity of the function 2x square minus 1 at x equals to 3. So this is also a continuous function because this is also an algebraic function. If I come to the third question, even third question also, each and every function is a continuous function. Here I use first question, algebraic function. Here I use 1 upon x minus 5 at x equals to, x is not equals to 5. So here you can use the fraction of, like, let me write this question here. This is third question. What is given? F of x equals to 1 upon x minus 5, right? Let me insert the expression. F of x equals to, this is going to be 1 upon x minus 5, where x is not equals to 5. So, okay, this is a given function where x is not equals to 5. That if you want to mention, you can mention. Otherwise, if you want, let me x is not equals to 5. Now, how do I check? This, I think we already solved this example in the last class. That's the denominator function. Let me show you, which we already explained, I think. Is there any question here? What happened? Somebody is exiting the class. Sharpit is still left. Did we solve in the last example question anywhere? Yeah, somewhere here. This one, 1 upon x we solve. 1 upon x example, I explain how this is continuous function. The same way you can discuss about 1 upon x minus 5 where x is not equals to 5. So what you can do is, there are two ways. Another way is I'll explain, just let me write. G of x equals to 1. I am trying to use the identity, and now g of x equals to, let me put x minus 5, and some h of x will be equals to 1 upon x. I'll write my functions as this way. Then I'll go for f of x function as the composition of two functions, which is, should I put GOH or HOG? I'll go for HOG of x. Okay, the composition of two functions I am trying to write. I have taken denominator x minus 5 as g of x function and 1 upon x as h of x. So it is HOG of x as a composition function. I can write h of g of x. This you can write, or maybe let me put here closed interval, because that curly brackets we use for the function, which is equals to h of, your g of x is going to be here in place of g of x, I replace it as x minus 5. So it is going to be x minus 5, which is equals to, now here I have h of x is 1 by x. If x is there, I am putting it as 1 by x, but in place of x you have x minus 5. So according to the h function, this will go as 1 upon x minus 5. Okay, this x minus 5 whole term is in the denominator only, 1 upon x minus 5. So that is nothing but f of x function only. So here I can say g of x is a continuous function. Okay, and h of x is also a continuous function. The composition of two continuous functions is also a continuous function. Okay, that's one of the property we discussed here. The addition of two continuous functions is continuous. The subtraction of two continuous is continuous. Product, division, or composition of two continuous functions are continuous functions. Okay, so all these properties we already discussed. According to those properties, this function is going to be a continuous. This way also we can solve it. Is it clear? Just a minute. Let's decrease the zoom here. Yeah. Everyone understood that question explanation, how it is a continuous function? Okay. So then I'll move to, I think rest of this is mod x minus 5. Okay. One, you can say modulus function is a continuous function. We have already that property. Or you can use the composition of functions, like take g of x as x minus 5 and h of x as mod x. Then you can prove it is a continuous function. Okay. So anyway, you can use that one. Next, prove that x power n is a continuous at x equals to n, where n is a positive integer. X power n is again a polynomial, I mean algebraic expression, and every algebraic expression is a continuous function. That way you can put it. Okay, so hence it will be a continuous function. Now question number 5 is the function defined by f of x equals to x if x is less than or equals to 1, and it is 5 when x is greater than 1. So I have to check continuous at x equals to 0 or not. Okay, if I put x equals to 0, which condition I have to consider? I have to consider 0 is less than 1. So x is less than 1, the function is going to be f of x equals to x only. So what I do here, it is question number 5. Let me insert the equation. limit I have to check x tends to 0. X tends to 0. Here f of x is going to be x because 0 is less than 1. If x is less than 1, f of x is going to be x only. Okay. So it will give me answer as 0 only. And even if I find f of 0, f of 0 also will give me 0 only because if you want, let me put here one condition. Here my function is going to be f of x is equals to x. Sorry, not 0. F of x equals to x because I'm thinking of limit of a function at x equals to 0. 0 is less than 1. If it is less than 1, my function is going to be f of x equals to x. Now limit x tends to 0, f of x I replace as x. So that value is going to be 0. Even if I find f of 0, f of 0 is also coming as 0. So limit value and the functional value both are same. Hence, f is continuous at x equals to 0. Now, what else they ask? You have to check the continuity at x equals to 1 and at x equals to 2. Now, when I talk about at x equals to 1, left side of 1 means less than 1. My function is x, f of x equals to x. And the right side of the 1 means the numbers which are greater than 1. So greater than 1, my f of x is going to be 5. So here I'll check the continuity of the function at x equals to 1. So let me put here at x equals to 1. So you can underline this one as we are going to check for the continuity of the function at x equals to 1. So let me see what I get here. Yeah, what I check limit x tends to 1. Instead of 1, I have to put left of 1 or right of 1 because here functions are different. Limit x tends to, I go for left of 1, 1 minus. So 1 minus means less than 1. Less than 1, my function is going to be x only. So if I substitute x equals to 1, I'm going to get the answer as 1. Now when I comes to right limit of the function, let me see what we get. So here limit x tends to, so here I have to put right of 1. Right of 1 means it will go as 1 to the power plus. Right side of the 1, my function is going to be f of x equals to 5. So here I'll get 5. As it is a constant function, you can see. So the answer is going to be 5 only. So here my left limit of 1 is coming answer as 1 and right limit answer is coming 5. Hence left limit is not equals to right limit. So f is not continuous at x equals to 1. Okay. So it is continuous at x equals to 0. It is non-continuous or discontinuous function at x equals to 1. And they also asked for the continuity at x equals to 2. At x equals to 2 means which is greater than 2. So left of 2 is 5. The functional value will be 5. Right of 2 is also the functional value is 5. Hence the function is continuous. Now you may ask, sir, if you are telling me left of 2, if I take 0, okay, when I say left of 2, 0 is also left of 2 only. So, but when I say limit of the function, when I discuss about the limit of the function, I don't go too far from the number. Okay, from 0 to 2, the difference is 2. So I'll not take that much difference. When I discuss about the limit extends to 1 minus or left of 1, or limit extends to 1 plus, that is right of 1. Okay. So what happens is the functional value within the boundary of 1, maybe with the radius of 0.1 or with the radius of 0.5 or with the radius of 0.05. Within that radius only, I am going to discuss about the limit of the function, not 1 centimeter distance or 2 centimeter unit radius. So we are not going to go that much far. So that's why when I discuss about limit x at x equals to 2, we are not going below 1. Okay. So in that case, left of 2 and right of 2, both functional values are going to be 5 only. So hence they are continuous. Student, just hold on. I think ma'am is calling for some work. Hello. Ma'am, good morning. Yeah. Can you hear now? So you can say at x equals to 2 also the function is continuous. Now here from question number 6 to 12, I'll discuss one or two questions. For example, let me go for question number 2, or maybe we'll explain. Find all the points of discontinuity of f where f is defined by, for example, question number 6. At x equals to 2, I have to check the continuity of the function, whether it is continuous or discontinuous. For example, if I want to find the left limit of the function, that is x is less than or equals to 2, your f of x is going to be 2x plus 3. So what do you get here if I substitute x equals to 2? 2 to the 4, 4 plus 3, 7. So left limit is going to be 7. And when I come to the right limit, that is x is greater than 2, my function is going to be 2x minus 3. Right? So 2 to the 4 minus 3. 4 minus 3 is 1. So left limit answer I got as 7. Right limit answer I got it as 1. So both are not equal. So hence your sixth question is discontinuity function at x equals to 2. Is that understood? Yes, student? Or do you want me to write the test? 3 questions I'll write, no doubt. Okay. Understood. Good. Now, seventh question. Here you have 3 steps are there. If x is less than or equals to minus 3, my function is going to be mod x plus 3. When x is greater than minus 3, function is going to be minus 2x. And x is less than plus 3, function is still minus 2x. And x is greater than 3, function is going to be 6x plus 2. So here I am going to discuss the continuity of the function at x equals to minus 3 as well as at x equals to 3. Because left of minus 3, right of minus 3, both the functions are given. Similarly, left of plus 3 and right of plus 3, here also both the functions are given. So I can discuss the continuity of the function at x equals to minus 3 and at x equals to 3. So let me write the question here. This is seventh question. So we'll solve it now. First, f of x equals to, what do I get? F of x equals to, what is the function is given? Mod x plus 3, right? So let me insert the equation for modulus. This is mod x plus 3 when x is less than minus 3. And the second step I'll write is, and f of x equals to, what is the function is given? Next function, minus 2x. F of x equals to minus 2x when x is greater than minus 3. So these are the two question steps they are given as. So let me go for the limit value of the function. Limit x tends to, first I'll go for left of minus 3. So left of minus 3 will come as minus 3. This is left of minus 3. F of x. If you want, you can write the step like this, one step. Then you have limit x tends to. Now here f of x is going to be mod x plus 3. Okay. Mod x plus 3 will come. This is my f of x. Now if I substitute minus 3 here, it will come mod of minus 3 plus 3 will come, because x value here it is going to be minus 3. So substitute minus 3 in place of x, it will come mod of minus 3, and this plus 3 will remain as it is. So I kept plus 3 here. Now what happens here? Mod of minus 3 is going to be 3 only, plus 3. So 3 plus 3 equals to 6. This is what I got the left limit value. Now when I go to the right limit, let me insert the equation again for the right limit. So what do you get here? It is limit x tends to minus 3 on the right side. So it will be minus 3. Here it will come as a plus sign. So f of x will come, which is equals to limit x tends to, instead of this minus, here plus sign will come. Now what do you get here? My function, if x is right side of minus 3 means greater than minus 3, my function is going to be minus 2x. So in place of plus 2x, I'll put minus 2x, which is equals to minus 2 times of minus 3. So hence that is going to be 6 only. So minus 2 into minus 3 is going to be minus 6. Now I got left limit as plus 6. Right limit as also plus 6. Now I have to find the functional value. Functional value means here what is the equal sign? If x is equals to minus 3, here it is given. If x is equals to minus, I got mod x plus 3. So here I'll come, next step, f of minus 3 will come. Functional value is f of minus 3. Yeah, f of minus 3 equals to, it will come mod of minus 3, then plus 3, which is equal to mod of minus 3 is 3 plus 3, which is equals to 6. I hope by this example you understand what do you mean by left limit, what do you mean by right limit, what do you mean by functional value. Here you may ask why you are considered mod x plus 3 only instead of minus 2x in the functional value, because here you see x is less than or equals to minus 3. So equals to there means when x equals to minus 3, then also my function is going to be mod x plus 3 only. So equality sign is there. So that's why I have choose f of x, the function f of minus 3 as this function, mod x plus 3. Now all the three are equal. This is also plus 6, this is also plus 6, and functional value is also plus 6. All the three things are equal. F is continuous at x equals to minus 3. Okay. Now you have to find the continuity at x equals to 3, whether the function is continuous at x equals to 3 or not. So I'll explain it orally. See, left of 3 means x is less than 3. So my function is going to be minus 2x. So minus 2 into 3, it will be minus 6. So left of 3, I got it as minus 6. And right of 3, which is x is greater than 3. X is greater than 3, my function is going to be 6x plus 2. So 6 3 is 18. 18 plus 2, 20. Left limit is minus 6. Right limit is plus 20. They are not equal. So hence f is discontinuous at x equals to plus 3. Okay. This example is clear. How to decide continuity, discontinuity. I think your replies are coming late to me. Okay. So here also you have to 8th question, 9th question, 10th question, 11th question, 12th question. The same way you have to solve. So here you have to be careful when you have the modulus function. If you want, let me solve question number 8, I think. What is the question number 8 is given? Mod x upon x if x is not equals to 0. Okay, x is not equals to 0 means whether is x is less than 0 or x is greater than 0. Both the cases, mod x upon x. So let me solve the question number 8. I think you may get action. Let me go to the next page. What is the function is given? F of x equals to mod x upon x. So we want to get a fraction, and here I'll put mod x upon x, where x is not equals to 0. So whether it is left function or right function, the function is going to be same only. Now let me check left of 0 and right of 0 whether the function is continuous or not, whether you are getting the same functional value or not. Limit extends to, if I go for left of 0, this is going to be 0 minus, which represent me left of 0. My function is going to be same function. Okay, so which is equals to, I'll get limit extends to 0 minus. Now 0 minus means left of 0. Left of 0, you know, all you have negative values. Am I right? Left of 0 is all the negative values. X is less than 0. X is less than 0 is the same negative values. What your modulus definition says, modulus of x tell me if x is less than 0, mod x equals to minus x. So according to the definition, here you are going to get minus x, because I am going for left of 0, all are negative numbers, that is x is less than 0. If x is less than 0, according to the definition of modulus function, mod x is going to be minus x, and the denominator x will remain same. So which is equals to limit extends to 0 minus x upon x is going to be minus 1. So hence this answer is going to be minus 1. I got my left limit answer as minus 1. Now let me go for the right limit answer. Limit extends to 0 plus. You have mod x upon x. Sorry, let me copy. Let me copy this step. Yeah, which is equals to, here you have limit extends to 0 plus. So if it is 0 plus, which means right side of the 0, which is x is greater than 0. When x is greater than 0, mod x definition says x is greater than 0, then mod x must be equals to x. So it will be x upon x, which is going to be 1. The limit extends to 0 plus 1 will come, which is 1 only. So what you got, left limit as minus 1 here and right limit as plus 1. So if both are not equal, hence f is discontinuous at x equals to 0. Okay, so this is what we have to conclude for all the questions. Now you can try the question number 9. Question number 10, 11, 12, these all are easy. Even question number 13 also. Is the function defined by f of x equals to this one is continuous function or not? Even question number 14, 15, 16. In 14, question number 14, you have to find the continuity at x equals to 1 and at x equals to 3. At x equals to 0, you no need to find because x is greater than 0. That means right limit you can find, but I don't know what is the function for the left limit when x is less than 0. Okay, that's why at 0 you no need to find the continuity. And at 10 also, x is less than 10, I know the function value is 5. I don't know what is the function if x is greater than 10. It is not mentioned in the question. So that's why at 0, at 10, I don't discuss the continuity. I have to find the continuity at x equals to 1 and at x equals to 3. I think this will come discontinuous only. Just check it out. Because f of x is less than 1, my functional value is 3. X is greater than 1, functional value is 4. So 3 is not equals to 4. Similarly, at 3 also the function is going to be discontinuous. Even this also you try, 15th, 16th also you try. 17th I'll explain you now. Find the relation between a and b so that the function f defined by f of x equals to ax plus 1 when x is less than or equals to 3 and bx plus 3 if x is greater than 3. So let me copy this question number 17. F of x is equals to what is given? It is ax plus 1 when x is less than or equals to 3. Am I right? Yeah, x is less than or equals to 3 and bx plus 3. Second condition which they have given is bx plus 3 when x is greater than 3. So this is what they are given. And one more condition is they are given. Find the relation between a and b so that the function defined by this is continuous at x equals to 3. So in the question itself they mention f of x is a continuous function. So as f of x is a continuous function, then the left limit and right limit must be equals to one another. Okay, so let me find the left limit. So you'll get equation limit. So I have to find the limit at limit extends to 3 minus. So this is my left limit which I have. What is the function is given for x is less than or equals to 3? It is ax plus 1. So if I substitute x equals to 3 here, then I'll get here it is 3a plus 1. Okay, so this is my left limit. When I want to find the right limit, so let me write here right limit as limit extends to is going to be 3 plus, so my function is going to be bx plus 3, which is equals to, now if I substitute x equals to 3, it is going to be 3 times of b plus 3. Now what is the condition is given? It is a continuous function. If it is a continuous function, then left limit of the function f of x must be equals to right limit of the function. Let me change this minus s plus. This is going to be f of, okay, both left limit and right limit must be equals to one another. Then only the function is continuous function. Okay, so what I got left limit, I got it as 3a plus 1 must be equals to 3b plus 3. Left limit is 3a plus 1 and right limit is 3b plus 1. So 3a plus 1 equals to 3b plus 1. If I simplify this one, finally I end with 3a minus 3b minus 2 is equals to 0. That's it. This is the answer, because they ask you to find the relation between a and b. So hence we got the relation between a and b. Okay. So that's what they're going to see. In this question, they clearly said f is continuous at x equals to 3. So they are given continuous. So if it is continuous, I know left limit, right limits are equal. So I equated them, left limit and right limit. Then I got the relation. Now similarly, if I come to the question number 18, find the value of lambda if the function is continuous at x equals to 0. Okay. So similarly, you find the left limit, you find the right limit, and equate them and see what functional value will come. Are we able to find the lambda value or not? They also ask what about the continuity of the function at x equals to 1. X equals to 1 means it is greater than 0. So left of 1, right of 1, my function is going to be 4x plus 1 only. Even f of 1 is also 4x plus 1. I think at x equals to 1, the function is going to be continuous. Next one, 19th question. Show that the function defined by g of x equals to x minus greatest integer function is discontinuous at all integral points. Here, close the bracket x denote the greatest integer less than or equals to x. See here, g of x is x minus step of x. Let me write here. This is question number 19. You will get question number 19. G of x is given as x minus step of x. This is what the function is given. G of x equals to this one. So here we have to think, which I equal and I did not say. Yeah. Here what you have to understand is x is the algebraic function. I know it is a continuous function. Every algebraic function is a continuous function. But in the last class, I explained the step function is a discontinuous function. Last class we discussed, because the graph of the function is a staircases. 0 to 1, it will take 0. 1 to 2, it will take 1. So 2 to 3, it will take 2. So step by step, the graph of the function is not continuity. After every integer, the graph breaks. If you want, you can see somewhere in the book they are given this. Yeah, this is the step function graph which we discussed in the last class. So at every integer, the graph is breaking. At 1, left of 1, the function value is 0, and the right of 1, the function value is going to be 1. Similarly, at 2, left of 2, that is less than 2, the functional value is going to be 1. Right of 2, that is which is greater than 2, the functional value is going to be 2. So that's the every integer, the function is going to be discontinuous. Okay, here first function is continuous, second function is discontinuous. So obviously the subtraction of two functions is going to be a discontinuous function. Okay, so that way you can conclude that 19th question is discontinuous function at every integer. Integral value means every integer. It is a discontinuous function. Now, when I come to the question number 20, is the function defined by f of x equals to x square minus sin x plus phi is continuous at x equals to phi? Yes, it is a continuous function because x square is a continuous function, sin x is a continuous function, and phi is a constant function. It is also a continuous. Hence, the combination of continuous functions will be again a continuous function. Anyhow, sin pi is going to be 0. Okay, so left of sin pi is towards 0 and right of sin pi is also towards 0. So 20 is also a continuous function. Next, 21 question, discuss the continuity of the function. Here also, sum of two continuous function is continuous. Difference of two continuous function is continuous. Product of two continuous function is continuous. Like this you can discuss. Even 22 also, cosine, cosecant, secant, cot functions. Cosecant is continuous except where sin x is 0. Secant is continuous except cos x is 0 because secant can be written as 1 upon cos. So cos is in the denominator, cos x cannot be 0. And tangent is also continuous, cot is also continuous except where sin is non-zero. Okay. Now I'll come to the question number 23. Let me solve. If x is less than 0, f of x is going to be sin x upon x. So let me solve this question number 23. So what will come in the question number 23 is, let me insert the equation, limit x tends to, I'll go for left of 0, limit x tends to 0 power minus, this is left of 0. My function is going to be sin x upon x. Can you find out any identity which we discussed in class 7? Limit x tends to 0, sin x upon x. Anyone has the idea about this identity? No one? No answers are coming. So if you remember, limit x tends to 0, sin x upon x. So the answer is going to be 1. Just recall the class 11th answer. So the answer is going to be 1 only. So left of 0, you got answer as 1. Now what is the right of 0 is given? If x is greater than or equals to 0, my function is going to be x plus 1. So when I find the right limit, let me copy here. Instead of your minus, it has to be plus. So my function is given as x plus 1. So when I solve this one, I'll get 0 plus 1. So which is going to be 1 only. So left of function is 1. Right of limit is also 1. Even the functional value is also going to be 1. Because if x equals to 0, it is x plus 1. If you want, you can write here. F of 0 is going to be 0 plus 1. So which is equals to 1. Okay, so left limit, right limit, functional value, all three are equal. Hence, the given function is continuous at x equals to 0. So like this, you can solve the question number 23. For 24 also, you solve the same way. Okay, write out. Then this also you can have to apply left limit, right limit, and all. Maybe from question number 26, you try it out. If you are not getting, then next class we will discuss. Okay, I'll make the video regarding this topic, question number 25. I think you will get it. Not that much difficult, but still you try it out. Is that topics are understood? Or still any doubts? Yes, student. What about others? Home not understood. You can turn on your mics. Yeah, no doubt.